Alright, welcome back to quadratics. Here we have quadratic applications, notes, and practice problems. So we are applying our quadratics, what we know, to something in real life. So in the first example, Mr. Johnson jumped off a cliff into the ocean in Acapulco while vacationing with some friends. His height as a function of time could be modeled by the function h of t equals negative 16t squared plus 16t plus 480, where t is the time in seconds and h is the height in feet. How long did it take Mr. Johnson to reach the maximum height? So what I would do, quadratics in general, they look, would something look like this. It would be, you'd be up on a cliff and you're jumping off, you jump up and then you go down. That'd be the quadratic. So how long did it take Mr. Johnson to reach the maximum height? So maximum height is what we're going to have to work on that. So that's going to be your vertex. And to find the vertex, you're going to do x equals the opposite of b over 2a. So we have a is negative 16, b is 16, and c is 480. So we have x equals the opposite of b over 2 times a. So that's negative 16 over negative 32, which simplifies down to 1/2. So how long did it take me? It only took me half a second to get up to my maximum height. Now, what was the highest point? The highest point, so the 1/2 second is your x value. We need to figure out the y value to figure out the maximum height. So we have h of 1/2. I'm substituting 1/2 in for time. So we have 16 times 1/2 plus 480. I'm going to do this all by hand. You can do this in a calculator, but it's really good to practice doing this. So we have exponents first. So exponents of fractions means you have 1 squared and then 2 squared. So 1 squared is 1, 2 squared is 4. I'm going to multiply the fraction out here. 16 times 1, multiply the numerators. So multiply the denominators. 1 times 2 is 2. There's 16 over 1, negative 16 times 1, multiply your numerators. So multiply those, you get negative 16. Multiply your denominators. 16 divided by 2 is 8. Plus 480. Negative 16 divided by 4 is negative 4. Plus 8 plus 480. So that's 4 plus, so it's 484 feet. That was my maximum height. 484 feet. What was Mr. Johnson's initial height? So initial height, you gotta think, what was the time of the initial, like right when I was here, like right as I started jumping, right before I started jumping, what was my initial height? What was my time? Well, time is 0 at that point. So if you substitute 0 into the function for time, you have negative 16 times 0 squared plus 16 times 0 plus 480. Well, all those zeros, 0 squared is 0, multiply times 0 is 0. It's actually going to end up being 480. So it's 480 feet high is where I started. That's all. That's super high. All right. So number 1 is very similar to this. I guess we talk about it. I'll work it out. How long will it take the rocket to hit the maximum height? Again, this is going to be your how long. This is the negative b over 2a. What is the maximum height? You're going to substitute the x value in. So I guess I could talk also. We have our A, we have a B, but we do not have a C, so the C is going to be 0. How long until the rocket hit the ground? So when you're looking at a graph, oh yeah, I'm sorry, this should be a squared also. Negative 16t squared. So negative 16t squared, negative 16x squared, plus 128t. When you're looking at this and asking ground, the ground is actually at the x-axis. So where does it hit the ground? Well, it's at 0 and 8. So how long does it take it for the rocket to hit the ground? It's at 0 seconds and 8 seconds. Well, it didn't go up if you're at 0. That's the start. So it'd actually be at 8. And here's how you mathematically do this. So we have negative 16 t squared plus 128t. I'm going to factor this. You could use a quadratic formula to find the x intercepts. But I'm going to factor greatest common factor here is negative 16. I can divide both of these by, well, 16t, but I'm going to pull out the negative since the a is negative. Not a big deal if you didn't. So it'd be a negative 16t. Negative 16t squared divided by negative 16t is t. And then 128 divided by negative 16 is a negative 8. Okay. Now if we set each factor here equal to 0, because that's what the ground is, where x, or the y value is going to equal 0. We set each of these to equal to 0. We have a negative 6, each factor equal to 0. And t minus 8 equals 0. You solve both of them. 0 divided by negative 16 is 0. So there's the 0 that you saw in the graph. And then adding 8, you get t equals 8. So you get 8 and 0. 0 doesn't make sense because you did not take off to reach the ground. You were already on the ground at 0. So 8 seconds. All right, I'm going to jump to the back. So a rectangle has a length that is 4 meters more than its width. The area of the rectangle is 117 square meters. Find the dimensions of the rectangle. So we're going to draw a diagram of a rectangle. It does not matter if you do a longer rectangle or a taller one. It does not matter. In the problem, we are told that the length that is 4 meters more than the width. So the length equals 4 meters more than the width. So it's width plus 4. We don't know what the width is, but we know that the area of a rectangle is 117 square meters. Every time we're talking square anything, that's the area. So area equals 117 meters squared. Now, we're talking area, so that's length times width. And since we know area is 117, we're going to replace the a with 117. We know the w is w. And we're going to represent the length, not as L, but as w plus 4, because that's what length actually is. And now you can see we only have w's in the problem. And when we multiply this out, w times w is w squared. There's our quadratic that is now born. We have a quadratic problem. So now we can see that with this quadratic, we have more than one w in the problem, so we cannot solve by square root method. We are going to, whoa, I'm not right with a highlighter. We're going to subtract 117 to make this quadratic equation in standard form where it's equal to 0. So then we can figure out how to actually solve. Now for this, we could solve by factoring. Hopefully it works, not a guarantee. We could solve by the quadratic formula, or we could solve by graphing. I would actually go to the quadratic formula if I couldn't graph, but this I'm actually going to graph on the Desmos just to save time in this case. So we have, instead of w, I'm going to write x squared because it's the x-axis, and we have plus 4w, so plus 4x minus 117. Looking at the x-axis, we have negative 13 and 9. Negative 13 and 9. So the w is going to equal negative 13, and w is going to equal 9. Well, does the width of negative 13 make sense? No, you can't have length or any measurement be negative. So we have 9 meters. That's the width. Okay, so the width equals 9. What does the length equal? Well, that would be 9 plus 4, so the length is going to equal 13 meters. Oh, I did all that in step 1. Write the equations using the formula. Here we go, that's here. Find the solutions. I'd use Desmos. If you didn't use Desmos and you wanted to factor it, you certainly could. The factors would end up being w plus 13 and w minus 9. You set each factor equal to 0. So this is if you didn't do Desmos. So you subtract 13, you get negative 13. You add 9, you get 9. The negative 13 doesn't make sense, 9 does. Now substitute back in the 9, and you get the length is 13. Hopefully this helps. If you have any questions, please come into advisory or come see me. Thanks.